If there was ever a perfect example of how an invention dominates us, this is it, isn't it? It's altered everything, from the way we organize work, to the way we scurry around, to the way we let complete strangers into our ear when we'd never let them into our house. And above all, the world's economy only operates now because we can talk to each other across continents at virtually the speed of light. Without long-distance communication, the modern world would not function as it does. That's obvious. Take this equipment, for instance. It's a receiving system in contact with a navigational satellite 600 miles up, circling the Earth north-south, so that as the Earth turns beneath it, the satellite covers the entire globe. Now, as it comes over, it broadcasts two things. It says where it is, and it sends out a continuous note at a very precise frequency. Now, if you compare that note to the sound, say, of the whistle of a train. As the train comes towards you and goes away, the note rises and then falls, like this. Now, the way the note rises or falls depends on where you hear it from. If you knew exactly where the train was, then what you were listening to would tell you where you were, because you'd only hear it that way in that place. And that's what this equipment does. There's the receiver locking into the signal from the satellite. Now the computer is working out the one location on Earth where a satellite at that particular point in space would give it the noise it's hearing. Okay, here's where we are. North, 43 degrees, 42 minutes, 12.1 seconds. East, 4 degrees, 43 minutes, 18.8 seconds. Right, you check those numbers out on a map, and this is where it says we are. South of France, near the town of Arles, at a position accurate to within 30 feet, precisely there where it says there is an ancient aqueduct. There it is. Telecommunications can pinpoint somebody, like that did. Or because he picks up a telephone, or because he's on a computer data bank. We organize ourselves better because of that. The question is, how well organized will we become? Too well? To a certain extent, the modern world would fall apart without that organizational ability. The new community of nations that has grown up from the bits and pieces of the old European empires, the French, the English, the Dutch, the Spanish, the Portuguese, is held together because we can organize. But what will that organizational network, that communications network, do to us next? Well, the answer to that question may lie in the past, because this kind of situation's happened before. The last time a world empire fell apart was about 1,500 years ago. Then the empire was Roman. Now, this is the accepted view of the fall of Rome, you know, rape and pillage, destruction the way Hollywood does it. But what really let the barbarians walk all over the Romans was something it won't take you a second to sympathize with. The taxes were too high to pay for the army that was losing all the battles, and a bunch of freeloaders in government, and of course, to pay for thousands of civil servants. So, for the Western Romans, better the barbarian you didn't know than the tax collector you did. So, the place fell apart. The imperial provinces cracked up into small barbarian kingdoms. And all that big-time stuff you have to have with imperial government, you know, superhighways, theatres, aqueducts, were no longer worth the upkeep. That's why we're here, outside Arles. This aqueduct fed the biggest industrial complex in Europe with water to run the wheels of the great grain mills at Barbegal. 28 tons of flour a day, a technological marvel perhaps to be lost forever in the chaos. All through this period, the so-called Dark Ages, the one organization that still functioned internationally, still traveled the Roman roads when nobody else would, handling the king's local and foreign affairs because its members could still read and write, was the church. It had a fully operational network of communications from bishop to bishop throughout Europe, and that's what held things together. The church then was like our telecommunications now. And so the knowledge that the monks had accumulated gradually spread. Knowledge like how Barbagal had worked, with the great water wheel and the gearing system that made it so efficient. And in the end, by the Middle Ages, look what they did with that wheel. Here's the wheel being operated by water, and here's the gearing system turning the horizontal movement vertical, then horizontal again, and then vertical again in order to operate the millstones. Here's another system operating a trip hammer for bashing things like mineral ore or cloth or leather, soften it up. Here's a system that operates a similar trip hammer device, but it's to work a suction pump for a water supply. Same system again, operating two levers, pressing on bellows for a blast furnace. And finally over here, a crank that turns a circular movement into back and forward movement for a sawmill. Beautiful system. So, put yourself in their position. The wars are all over. There's loads of productive land everywhere. You've got water coming out of your ears and an amazing machine to use to harness the power. What would you do? Yes, you'd have yourself a medieval industrial revolution. The great thing about these wheels was that they were easy to make and they'd work almost anywhere. You lived up a mountain, hollow a few trees out, and you had yourself a wooden aqueduct. Horizontal wheels didn't need gears because they spun millstones directly above. You could turn a vertical wheel with water falling from above or flowing past below in a river. And with gears, you could slow down the effect of a fast stream or speed up a slow one. Water power made you a lot of bread, in both senses. But the star of the show was this, the cam. With a cam, you can trip hammers to pound things with, harder and faster than any human being. And build yourself mills to work. Timber, oil, grain, leather, cloth, iron, beer, wire, sugar, coin, you name it. It took a lot of energetic monks to get it all together. Now, they were energetic because in 1098, a bunch of Benedictines, fed up with the luxury and the ritual, lit out for the wild country and the simple life. And St. Benedict's original idea that hard work was good for the soul. But it was the way these Cistercians organized themselves that turned them into a medieval multinational and gave Europe systems management. See, each monastery had to be self-sufficient in food, so they cut back on the praying and added 6 hours labor a day. They went into rearing animals, clearing and draining land, they went out looking for new plants they could grow, and they wrote each other reports on the latest developments. Like this one, growing vines on bad land, hillside terraces. They used all the technology available, wine presses, water mills, iron foundries. A Cistercian abbey was like a corporation, with the special advantage that at the end of a hard day's business, they served the house wine in the company canteen. Mind you, the food wasn't that hot. No meat, they sold all that, just vegetables, nettle soup, a few roots, bread, and silence while you listen to instructive selections from the Corporation Handbook on Getting Spiritual and Managerial Strategy Right, otherwise known as the Rule of St. Benedict.
Non veni facere voluntate meam, sed eius qui misit me.
Well, with this kind of organization, how could you fail? Within a century, there were nearly 600 Cistercian monasteries. These monks did everything with fanatical discipline. Nothing got in the way, no fancy architecture or ritual or color to distract from the corporate image of efficiency. And as their lands and their management techniques developed, the news spread to the world outside. Maybe their single biggest success was their sheep rearing techniques, because by the 13th century they were producing the best wool in Europe. So, there were the Europeans of the 12th century, with all that amazing water power technology and the red-hot industrial management systems worked out by the Cistercians, almost waiting for something to happen. Something that would generate enough money to trigger the economy off into high gear. And when that something happened, it was one of those examples of the way change can come about quite unexpectedly. Because the two inventions that were to trigger the great leap forward could never have been foreseen here in Europe, because they came from China. The Arabs brought them to us, and what a gift they were. The first one of those Chinese gifts was a new loom, and it immediately caused a problem. It speeded up weaving because the thread lifting business was now done by foot pedals, not by the weaver's hands anymore. The new loom produced cloth so fast, they ran into the problem of not enough yarn. See, up to then, you spun yarn in a way that hadn't changed for centuries. You teased the fibres out of the mass and hand-twisted them onto a spindle. It took hours. Then, in the 13th century, the second Chinese idea arrived and solved the problem because it produced yarn fast enough to keep up with the new loom. It was the spinning wheel. Early on, they didn't have much more than the wheel and the spindle. Foot pedals came later. But these two simple bits of machinery fitted together like bits of a jigsaw. And when they did, the places they were used got very, very rich. Places like Bruges. Bruges was one of the richest of the medieval cities built by the woolen trade, and if you know anybody called Draper, boy, were his ancestors well off. The cloth merchants made so much loot, they didn't know what to do with it. They built roads, canals, guild halls, cathedrals. They even had their own laws. And in spite of all that, they still had enough money left for high-technology music. Not just this kind of toy, the kind you can still hear in the cathedral towers all over Belgium, where the carillon still plays. Recognize the mechanism? It's the cam again, tripping levers that pulled wires that eventually pulled the clapper on one or other of a number of differently tuned bells. You set the cams in like pegs to trip certain levers and ring certain bells. Now, the reason all the good burghers had all these extra goodies was because they'd found a new market for their wool. See, all over Europe, people now had surplus, and surplus always looks for a ready market. South from Scandinavia and England and Flanders came fur and wool and cloth. North, through the Mediterranean, through Genoa and Venice, came silk and spices from the Far East. East, from France and Spain, came salt, wine, and Cordovan leather. And from Russia, fur, I suppose. Everybody's crossroads lay in the county of Champagne at 4 little towns where they set up the first international markets, called the Champagne Fairs. The biggest fair was held at Troyes, in those days half the size of London. And merchants turned up because they got a special safe conduct from the king and armed guards along the road. Of course, the town made a bit out of it too. You had to pay a license to set up your stall, and there was a sales tax, isn't there always? And you had to pay to come in and out of town. Not that any of this bothered the merchants, they just upped the price. Funny how some things don't change. Anyway, this international money-making went like a house on fire, especially among those able to turn up with the very, very rare stuff, like like silk, where you really made a packet. Most of the really fancy stuff was brought by the Italians, who practically ran the place. By 1275, there were no less than 15 Italian cities who had consulates here in Troyes. The reason the Italians mattered so much was because when everybody got back from a crusade in the Middle East to their rather dull northern European town, all they could talk about were the amazing luxuries of the mysterious Orient. Silk, cinnamon, pepper, elephant tusks. Things which the Italians were very well placed to provide at the fairs. The Venetians, the Genoese, and the Pisans all had trading colonies all around the eastern Mediterranean, where they could pick up stuff from as far away as China. Well, there was so much money to be made here. And given the fact that the Genoese have always had a reputation for being where the profits are, it's not surprising that it was probably they who came up with a way to keep the financial ball rolling, so to speak, with this thing. It's an investment contract called a commenda. Now, this is a copy, but this particular one was written on the 14th of November, 1244, and it's a contract between a travelling merchant called John of the parish of St. Genesius and a draper called Otto, there's Otto, who is investing 81 Genoese pounds as a share in a load of purple cloth and gold silk that John the merchant is bringing up here to the Champagne fairs. The agreement goes on to say that John can use his discretion as to where and when he trades, on condition that when he gets back to Genoa, Otto gets detailed accounts and his share of the profits. This tatty bit of paper, which looks like an everyday affair, thing you write in the back of an envelope practically, represents a really fundamental innovation, because it brought everybody, rich and poor, who had any spare cash in on the act. And that spread the risk, and that encouraged more merchants to go to more places. So the Champagne fairs and others, places like this, really boomed. It looked as if good times were here to stay. And then, at the beginning of the 14th century, came a change in the weather. Freezing winters and rainy summers. Bad harvests followed, and then famine. With little or no surplus crops to sell, money became tight, and the fairs began to fail. All over Europe, people tightened their belts. And in this weakened condition, they were virtually defenseless against attack. And when it came, in 1347, the effect was devastating. All the more so because they had no defense against the enemy. It was a flea. The flea carried the Black Death, and from when it arrived in Europe in 1347 on board ship from the Crimea to when it receded only 4 years later, it killed maybe 40 million people. 200,000 villages were totally wiped out. At the height of the plague, there weren't enough living to bury the dead. The flea sucked the disease in rat's blood, and when the rat died, it jumped onto people and bit them. The effect was appalling, from fever to abscesses in the groin and armpits to death inside 24 hours. Black pustules spread all over the body, which was why they called it the Black Death. The effects were particularly bad in the towns, packed with people busy making all that money. The plague ripped through them. And a new face appeared in all the pictures. And for those with itchy feet, a new kind of dance you could unexpectedly find yourself swinging to. The dance of death. One grimly enjoyable thing came out of it all. The people who died left their money to the people who lived. All they could hope for was that they'd survive to enjoy it. Well, no nightmare lasts forever. By 1351, the worst was over. When it was all over, the survivors went insane, trying to forget the horror they'd lived through. life everywhere in Europe became one long hysterical shindig. People spent the money the plague had given them on the wildest outfit they could buy. If you were rich, silk embroidered with gold wire was the thing. The middle classes went into expensive little numbers in wool and velvet. And the peasants? Well, thanks to that loom way back and the fact that flax is cheap to grow, linen was their thing. Well, it was everybody's thing, really, in hats and shirts and bed sheets. And especially if you take an indiscreet look up the nearest girl's skirt. That. Underwear. And just this once, that's the great historical trigger of change. What you're looking at now. Yes, frilly knickers. This is the first result of the great 14th century bed linen and underwear boom. The guy who used to go around collecting bones for fertilizer now started collecting linen too. He became a rag and bone man. Why? Well, that's the second result of everybody wearing linen, because when they wore it out, they threw it away. So there was this great pile of linen rag. And guess who went bananas about that? Okay, let me give you a clue. The first thing that happens to the linen in this process is that they take it and rip it against a knife to make the rags even smaller. And what is shredded linen rag absolutely perfect for making? Yes, paper. So the paper makers got an unexpected linen rag bonanza, pounded by hammers, tripped again by the can. You bash the rag in water and gum for 48 hours, and the sludge you get is paper pulp. Slosh that onto a wire mesh frame, count 5, and you've got yourself a sheet of paper. Well, a sheet of very wet paper. So the next thing you do, no prizes, is dry it. Funny coincidence, the wire mesh frame. A lot of wire makers about, making all that gold embroidery people had started wearing. Anyway, the paper. You lay each sheet between layers of woolen cloth to soak up the moisture. Looks more like a sheet of porridge, doesn't it? And when you've got a big pile of wool and wet paper sandwiches stacked up, you call the lads. All you do now is squeeze the pile in a press until you've got nearly all the water out of the paper when you hang it up to dry, and that's all there is to it. Funny how it all comes together here in the paper mill. The water power to run the cams, tripping the hammers to make the pulp, the wine press come linen press to squeeze out the water, and thanks to the automatic loom, the linen that makes the pulp. And because of all that free linen, suddenly the cheapest thing around was paper. This is one of those moments in history when things come together like a jigsaw to produce something entirely new. Look at the bits we've got so far. Because of the linen, we have cheap paper. The Black Death is just over, so the economy of Europe is on the up and up. Administration is expanding. There are many more clerks needed to do all the paperwork. However, the Black Death has killed half the clerks off, so they cost a great deal. So we have extremely cheap paper, and the cost of a man who writes on it has gone up astronomically. What do you need to solve that problem? Yes, printing. And that's exactly what happened. But before the final bit of the jigsaw could be put into place, you needed one particular skill, the kind of skill, say, a goldsmith has. If you come upstairs with me, I'll show you what I mean. You see, printing had been around for centuries, in the case of the Chinese for 1,000 years, but it was printing with blocks like this. The trouble was those blocks, being made of wood, would tend to wear down, and in any case, they only did the one thing. Now, what our goldsmith friend did, and by the way, his name was Johann Gutenberg, and he lived in Mainz in Germany in the 1450s, he used his expertise with precious metal. He knew what that was, the hallmark. And he knew that the hallmark was made with a punch. So he took a punch and he carved a letter on the end of it, and using the punch, he punched that letter into a soft copper bar. Then he designed a mold in 2 bits so that it comes apart. You put the mold together like that. You slide into the mold the letter you want to make, any letter. Close it tight with a big spring. Turn it over. And then very, very carefully, you put molten lead alloy into the mold like this. Leave it for just a few seconds, and then you break the mold, and the letter is there, ready to print with. And that letter A will go anywhere on the page you want to put a letter A. It will go in the place of any other letter A. The mold makes all the letters so they're all the same size. It makes all the spaces so they're all the same size. So the printing is uniform. But it's the interchangeability of the letters that is at the heart of Gutenberg's invention. If you think about it, it was a good deal easier for a European to do than, say, for a Chinese, because the Chinese language has thousands of characters, and if you made every one of them, you'd need a space as big as this printing room in Antwerp just to store them in. Whereas the Latin alphabet of the time only had 23 letters to be made. As for the printing itself, well, that was a bit of a cinch. This press was just an adaptation of a linen press that had been around for centuries, as had the ink and the paper. This is the first dated piece of printing we know of. There may be earlier ones, but this one has a date on it. And the people who did it were very proud of what they'd done. It's the introduction to a book of Psalms. And the text says, "This work, adorned with the magnificence of capital letters, was fashioned with the use of a mechanical process for printing and making letters without the use of a pen." And then it says the name of the 2 men who were so proud of what they'd done, Joachim Fürst and Peter Schoeffer. And then the date, 14th of August, 1457. The coming of the book changed everything. Perhaps the most obvious change was the appearance of the bookshop, where you could come in and buy anything you wanted to read. Knowledge was no longer the private property of the priest or the prince or the scholar. If you could pay and you could read, it was all yours. The new books also standardized spelling. They carried an author's name, and they encouraged accuracy because the books could be widely read by people who knew more about the subject perhaps than the author himself. But perhaps most fundamental of all, the new books gave birth to the specialization that is the blessing or the bane, depending on your point of view, of our modern world. Because you see, the architects and the engineers started to write about what they knew in terms that only their co-professionals would understand. The generation that first read these new books could as easily turn its hand to the lute or the sword or the architect's drawing. And because of printing, they were the last generation to be able to do that. The coming of the books must have seemed as if it was going to turn the world upside down in the way it spread and democratized knowledge. And one of the few men responsible for that spread was an Italian called Aldus Manutius. And he realized that what people needed and wanted was cheap, standard books that they could carry with them anywhere they went in their saddlebags. And so he produced the world's first pocket edition. And he did so in what by 1500 was the printing capital of Europe, Venice. Used to blow their own trumpet a lot, the 16th century Venetians. Well, you couldn't blame them. There were, after all, more millionaires per square inch here than anywhere else in Europe. Biggest navy, biggest overseas commercial empire, biggest bank balance. Venice was queen of the seas. Of course, there was nowhere else she could have been queen of. Not much land in Venice. She was a city full of businessmen, and because of her connections with Constantinople, she was also full of Greeks. refugees from when the Turks invaded it in 1453. And it was the Greek connection that gave the printer Aldus Manutius his big chance. Because Aldus got the Greek refugees to work for him, and because of that, his books gave the world a taste for the knowledge and the style of ancient Greece. He turned out dictionaries and grammar books first, so his customers could learn Greek, and then, of course, they could move on to reading the Greek books he would sell them. No fool he. Well, the new books got everybody turned on to matters ancient. One of the earliest bestsellers was a Roman thing on architecture that got people into big prestige building projects, people like Michelangelo. Thanks to Aldus and the Venetian printing presses, in 1500, only 50 years after Gutenberg, there were no less than 20 million books in existence. In 1515, Aldus died. Aldus Manutius was laid to rest with his books heaped around him as a mark of respect for what he'd done, which was to print every major Greek classic in existence and invent a new kind of letter type for his pocket editions. It was a kind of print that would pack a lot into a tight space. We call it italic. So now the world could start worrying about something it had never had to worry about before: the small print. But above all, thanks to books, the world learnt about Greek science. This was one of the books that made the greatest impact of all, by the Greek hero of Alexandria. It details how to make machines using the natural forces of air, or steam, or water as power sources. It's really talking about complicated toys. But this book and others like it put the world of Greek science and the ancient past into the hands of the armourers and the architects and the engineers working for the princes and bishops of 16th century Italy. And look how the armourers immediately begin to work in the antique style. On this tapestry, this bunch of soldiers, they're using the latest in handguns, and yet they themselves are dressed like Caesar's centurions. As the wealth of the mysterious East and West began to pour into Europe and the population began to soar, the princes also began to embellish their growing cities with elaborate water supply systems, operated by the same mechanical devices as were shown in the Greek and Roman books. And in their homes, the aristocrats would hang tapestries like this one, containing scenes of fantastic inventions like the flying throne, being carried into the sky by winged beasts that can never quite make the piece of ham above their heads. Or the mythical story of Alexander the Great, exploring the oceans on board a submarine. What the princes wanted were things, toys, that would show off their wealth and position in a way that would amuse and impress their friends. And now, their armourers and their engineers had the techniques to do it. One of the most famous armourers of the time, a fellow called Bartholomew Campi, switched, for example, from making this rather complex armour, a gauntlet, to making things like this. It's a clockwork tortoise carrying the god Poseidon, and it was used at the dinner table because they would set it down and it would take toothpicks from one guest to another around the table. The vogue for automatic machines spread everywhere, and with the help of the hydraulic engineers, it spread in a form that would bring people hundreds of miles just to take a look. This is one of the best ones still working, the castle of Hellbrunn outside Salzburg, built in 1615 so the Prince Archbishop and his guests could have a little water-powered fun and games. The whole place works on water turbines running the familiar cylinder with pegs in it, operating a 16th century Disneyland. The name of the game was to get the most unexpected things to spurt water all over the suckers who come to dinner. Everybody laughed, ha-ha, because the host was a prince. And besides, you got a free meal out of it all. Well, that's not all you got out of it. Of course, haha, you couldn't get up until the prince did, and of course, haha, he didn't need to. The craze for automatic machinery that spread through Europe came here too, of course. Here, the pegged cylinders run an entire village of mechanical puppets, working like the carillon in Belgium did on wires and levers. The whole thing's only 18 feet wide, and they packed 113 little people into that space. Over the top of all this water-powered wizardry, there was a mechanical organ to drown the machinery noise. And as you left, the prince would politely raise his hat. Mechanical organs and things might have stayed just that if it hadn't been for another craze sweeping Europe, a mania for Chinese fashions, particularly in dress, when, at the beginning of the 18th century, very complicated patterns became all the rage, especially in France, and particularly in silk. By the beginning of the 18th century, the demand for this kind of pattern was giving the silk weavers of Lyon a real headache, because silk weaving isn't just the simple over and under business of ordinary weaving, it's much more complicated. I mean, take a look at this. This already complicated pattern, if you follow it across, there you see suddenly for about 5 threads that particular orange. So it comes in, say, at thread 530, and it disappears again at thread 535. Now, if you get that one thread wrong, you've blown it. Let me show you on this little model loom here how they cracked that problem. Every thread runs through a tiny ring on a cord, so that if you want to lift the thread, you pull the cord up, the thread lifts, and in this case, the crossing thread would go underneath and in the final pattern not be seen. Now, if you tie together all the cords for all the threads that you want to lift into one bunch, then one pull will lift them all, like this. Now, in a complicated pattern, there would be a lot of those cords to pull, and the children whose job it was to do it would get tired and pull the wrong cords and maybe ruin a week's work. So in 1725, a Lyonnese weaver called Basile Bouchon solved the problem because his father was an organ builder. Because his father used these things for his automated organs. Remember the organs? Used the same cylinder with pegs in it to make music as they'd used in Belgium to work their bell-ringing carillon. And they'd originally got that idea from the cams set onto the shaft of the paper mill. Bouchon saw that the piece of paper that you give to the carpenter to tell him where to put these pegs on the cylinder was in fact a kind of control mechanism. So he put it on a loom. Look, each control cord comes over and down here, and whether or not it's moved depends on this horizontal needle here. Okay, now for the control mechanism part. What Basile Bouchon did was put a roll of perforated paper up against the needles, the cross needles, and where there was a hole, the needles stayed put because they came through the holes. And where there was not a hole, as in the case of these 4 needles here, the paper pushed the cross needles so that all 4 needles and all their threads operated simultaneously like this. And to change the pattern, you simply moved the paper along one row of holes. But the paper tore and the weavers placed it in the wrong position. So around 1740, another weaver from Lyon called Falcon came up with this idea. He put each pattern on a separate card. Now the card was more durable and you couldn't really mistake how you should position it. Around 1750, one of the greatest machine makers of all time, a man called Vaucanson, who was also the inspector for silk factories, automated the entire process. He put the perforated roll around a cylinder and mounted the cylinder on a chassis which went backwards and forwards on water power like this. And as it did so, it clicked forward one row of holes automatically each time. Now, that was limited to how much paper you could put around the cylinder, and it put men out of work. So for nearly 50 years, this loom mouldered unnoticed here in the Paris Museum of Arts and Crafts, until just after 1800. Another weaver who happened to be here at the time was asked to put it together, and in doing so he made a few changes. He put Vaucanson's idea together with Falcon's cards and came up with this. It's automated, and it has the advantage that if you want to increase the pattern, you simply add more cards. Now, for that minor amendment, he got all the glory, because to this day, the entire concept is named after this man. This is a Jacquard loom. And boy, what a success that was. Well, not in France, because the revolutionaries decided they didn't like fancy aristocratic patterns. But in England, where the loom ended up making things like paisley shawls very popular. And where these cards got picked up for a very different reason. They got used to control automatic riveting machines that by the mid-19th century helped to build the great new iron ships that were to make the crossing of the Atlantic safer and faster, just in time to handle the biggest load of passengers that any shipping lines have ever carried, the poor, huddled masses of Europe. And though they didn't know it, these immigrants were to trigger off the development of one of the modern world's most extraordinary inventions. By the 1870s, the immigrants were stepping ashore on American soil at a rate of over 7,000 every day. The journey across the Atlantic had taken anything from 12 days to 3 weeks, and most of them traveled in conditions that varied from bad to appalling. Many of the bigger ships were designed with only one thing in mind, to carry as many immigrants as possible. And so they came, in filth and degradation, packed in like cattle, treated much the same. The vast majority came to New York, at first to the immigration depot at Castle Garden, and then later here, to the place that was to become a symbol both of everything that America offered and the terrible fear that at the very gates of freedom they would be turned away, here at Ellis Island. It took only a few hours to be accepted or rejected, and much of that time was spent confused and bewildered, waiting, clutching their cardboard suitcases tied up with string, everything they possessed. Some of them, those who could write, even left their names on the walls, as if to say, look, I made it. And then came the moment of truth, the point at which they either passed or failed the test to become American. What none of them could have known was how easy that test was. A quick look at the eyes, the hands, and the throat, and then the writing down of their particular details. The point at which many of them lost their old names because the inspectors couldn't spell them and they couldn't write them. So they became Smith, Brown, Jones. 8 out of 10 people passed the test. But with one inspector handling 500 people a day, it was almost a case of, if you could walk, you were in. In the 30 years between 1850 and 1880, nearly 8 million people got in. And as the country grew and the frontiers pushed west, the immigrants were swallowed up to disappear in the vast open spaces of this enormous country. The trouble was, every 10 years, the government had to find them all again for the national census. And as the population soared, the paperwork for doing that became unbelievable. And then in 1880, an army surgeon called John Shaw Billings, who was working on the census, was watching the mountains of paperwork being shuffled when he happened to mention to his young engineer assistant that he reckoned that the Jacquard cards with their punched holes ought to be able to carry information. You know, if a man was married, you'd punch a hole, and if he wasn't, you wouldn't. The young engineer, Herman Hollerith, worked on the idea and came up with this. It's called a tabulator, and it works on cards like these, the size of a dollar bill of the period. Now, Hollerith chose that size because they already had holders for dollar bills, and what that meant was he wouldn't have to design and build one himself. No fool. So, you put the card in here. Now, let's say we're talking about a white male, aged 35, who is single, lives in Maine, and came originally from Russia. Right, you punch white, male, 35, single, the code for the state, Maine, and finally, Russia. Now you take the card out, see the little holes, and put it into this press. Now, when you push this press down, These little needles here with springs on them either go through a hole or they don't. Remember Jacquard? And if they do go through a hole, they make electrical contact down there. And that triggers these counters up here one click forward. Now, depending on what you want to count, you program the counters. Say you just want a general population figure, then all these are the states and territories, of which that is Maine, and that one in the corner is the grand total. So our man in Maine would add 1 to Maine and 1 to the grand total, like this. And the bell told you you'd done it. Now, the census involved much more detailed analysis than that. So Hollerith also designed a sorter, this cabinet with lots of boxes in it, connected to the tabulator. Now, let's say you want to take a particular look at all 35-year-old men. What you do is program the tabulator so that when one of them comes under the press, it causes a particular box to flip open, like this. And you pop the card into the box, and at the end of the day, you took out all the 35-year-olds and ran them back under the press to see where they all lived and to see how many of them there were. And you could do that with any bit of information on a card or any mixture of bits of information on a card. Well, the 1880 census had taken over 7 years to complete. With the new tabulator, the 1890 census was finished in half that time, and they checked the total twice. 62,947,714. So, the trail has brought us from the water wheel to the loom, and the linen it produced that made paper so cheap it spurred the development of printing, of books that interested people in things like automated organs, whose pegged cylinders gave the French silk weavers the opportunity to run their looms with perforated cards that Hollerith used to count Americans who had once passed through this hall in Ellis Island. Gateway to the one country that more than any other would fall apart if it weren't for Hollerith's card, used to program the computers without whose help the entire massive structure of the modern world would fall down. Most of the ancestors of the computer brought people pleasure. What will it bring us?